Students, in the previous video, you know what is thermodynamics and related terms in thermodynamics. These are your thermodynamic system, thermodynamic surrounding, your thermal equilibrium, your thermodynamic parameter or variables like your pressure, temperature, volume, your thermal equilibrium, how two states or two systems are in equilibrium, and also zeroth law of thermodynamics. And from this, what conclusion will you draw? Zeroth law of thermodynamics gives idea about temperature. How? Now, when two states are in thermal equilibrium, we say they have same temperature. So, from this zeroth law of thermodynamics, you can define temperature. What? This is a thermodynamic variable which is responsible for heat flow from one body to another body. So, this is the earlier video. Today, we will focus some terms like heat, work, internal energy. Students, if you analyze these three things, heat, work and internal energy, actually they have same unit. Unit of heat is your joule, you can say, though it is in calorie. Unit of work is joule. Unit of internal energy is also joule. Students, you know what is heat. Heat is nothing but a form of energy which is the thermal energy, and this thermal energy is due to the rotational, vibrational and your translational motion of the molecules. Students, you also know what is work. Work is nothing but the displacement of the body due to application of the force. I mean, one says work is the dot product of force and a displacement. And also you know energy. So, how to define these things in thermodynamics? First come to heat. Students, you know, suppose this is a container or vessel, you say, which contains gas molecules. This contains your gas molecules. This is your gas molecules. Here is a piston. Students, This is the piston. So this container or vessel contains gas as the system and a piston is connected. This is also known as your surrounding part. This is your surrounding, because this system may absorb heat from the surrounding. Suppose Q heat is given to the system. Also, this system gas rejects heat Q to the surrounding. I mean, in thermodynamics, there may be heat exchange between system and a surrounding. Students, so how to define this heat, or what is heat? Heat is nothing but mode of transfer of energy due to temperature difference. What I write? Heat is nothing but mode of transfer of energy due to temperature difference. I mean, if there is temperature difference between system and surrounding, you know, this is a system, this is also your surrounding. So if there is temperature difference between system and surrounding, your energy is transferred. So that is what your heat. So heat is the transfer of energy due to temperature difference between system and surrounding. Students, also we can say another point where heat is supplied to a system, heat is given to a system, the molecules of the gas, the molecules of the system move randomly. Means the molecules may move in this direction, in that direction, in that direction. In any direction, the molecules may move. That means when heat is given to the gas, its molecules move in a random direction. So we can say that there is transformation of energy between system and surrounding due to their temperature difference, and also due to that heat the molecules move in random. Students, you know unit of heat is calorie, and also you can measure in joule, and 1 joule is equal to how much calorie, or 1 calorie is how much joule. 1 calorie is equal to 4.18 joule, or you say 4.2 joule approximately. This is the conversion. If you know calorie, you can convert it to joule, or if it is in joule, you can convert it into calorie. So this heat is vital in case of a thermodynamic system. Here gas is the thermodynamic system and these portions are the surrounding. Students, when heat is given to the gas, what happens? Gas expands. I mean gas will expand. So what happens? Piston will move upward. So here, since gas absorbs heat, since system absorbs heat, therefore heat is taken as positive. And when the piston is compressed, the heat is released to the surrounding by the gas. When piston is compressed, the gas is compressed. I mean, when piston moves in this direction, gas is compressed. So in compressing the gas, heat is released or heat is given to the surrounding. And in that case, heat Q is negative. In thermodynamics, this sign convention is vital. In which case Q is positive, in which case Q is negative. Now students come to work. So what is this work? How work is done? When gas is expanded, we say work is done by the gas on the piston. I mean, when gas is expanded, piston moves upward. So work is done by the gas on this piston. And in that case, your work is taken as positive. I mean, during expansion of gas, work is positive. But when gas is compressed, I mean work is done on the system or on the gas. Two things. Work done by the system, work done on the system. This is system. If work is done on the gas, work done is negative. If work is done by this gas, work is what? Positive. Work done by this gas means the piston moves upward. Work done on the gas means the piston moves downward. So you know what is the sign convention for work done. W is positive when gas is expanded. W is negative when gas is compressed. Okay, students? But what is work? How can you differentiate from heat? In this case, you see, work is also transformation of energy. Heat is transfer of energy. Work is also transfer of energy. But heat is transfer of energy due to temperature difference. But work is transfer of energy due to no temperature difference. So due to what? It is the transfer of energy due to the motion of this piston. When piston is moved, work is done. Work is involved. So how can you differentiate work? This is also mode of transfer. Mode of transfer of heat, transfer of energy due to movement of piston. So this is what your work done. Or you say raising or lowering the weight connected to it, same thing. So this is the work. Another difference you can take, when piston is moved in a particular direction, the gas molecules move. When piston is moved in a particular direction, gas molecules move. That means the motion of the molecules are in an organized manner. But in the previous case, in case of heat, they move randomly. But in this case, in a particular direction, your gas molecules move. So students, you know what is heat, what is work, but this work and heat are differentiated in thermodynamics. This is mode of energy transfer, this is also mode of energy transfer, but one is due to temperature difference, another is due to motion of the piston. In one case, molecular motion is random. In case of another work, molecular motion in a particular direction. Q is positive when heat is absorbed by the gas or gas is expanded. Q is negative when when heat is released by the gas or system. Similarly, work done is positive when gas is expanded, and work done is negative when gas is compressed. Now come to students your internal energy, and you can know work have also the unit of joule. Same thing, students. Students, what is this internal energy? Energy, you know, various type of energy: mechanical energy, electrical energy, magnetic energy, nuclear energy. That is various types. But you know what is mechanical energy? This is nothing but kinetic energy and potential energy. Kinetic energy is due to motion, potential energy due to position. But in this case, what is this internal energy? This internal energy is what? Sum of molecular kinetic energy and potential energy of the system. This is the system. This gas is the system. So since gas molecules are in a random motion, so they have kinetic energy. And how potential energy comes? Students, you know, in case of solid or liquid or gas, there is intermolecular force. There is force of attraction between molecules. So in this case, in case of gas, also molecular force of attraction is there. So due to this molecular force, there is potential energy. That's why we say the gas molecules possess kinetic energy as well as potential energy. I mean the system or gas has internal energy. So this kinetic energy is a function of temperature. What does it mean? when temperature is varied, kinetic energy of the molecules vary. How? Suppose you give heat to the gas. So what happens? When gas is heated, when gas absorbs heat, it expands. The molecular motion increases. The velocity of the molecules increase. So due to increase of velocity, its kinetic energy increases. That's why we say internal kinetic energy is a function of temperature. Similarly, students, when these gas molecules expand or the gas is expanded, what happens? There is some work done. I mean, when gas molecules or gas expands, your work is done against something. You know, in case of potential energy, you are getting work done. How? Just taking the example. Suppose you are raising this body from this height to that height. So against the gravity, you are doing work. Work is done against the gravity. Gravity pulls this, but you are moving this. Or this body is displaced against gravity. I mean, work is done against gravity. Gravity pulls a body downward, but you want to move it upward. So against gravity, some work is done, and that work is the gravitational potential energy. Similarly, students, when you expand a rubber or expand a wire, work is done against the restoring force. You know, due to restoring force, the molecules of body comes to its original position. Suppose you expand, that comes to the original position. So against the restoring force, work is done, and that work is your elastic potential energy. Students, what is my point? For potential energy, work is done against some force. In this case, in the case of internal potential energy, work is done against intermolecular force. That means between gas molecules there is intermolecular force, but when it expands, when a gas expands, what happens? There is some work done against the intermolecular force. Intermolecular force tries to bind the molecules in that way, but due to expansion they move. So some work is done against the intermolecular force, and that work is the internal potential energy. So on which factor it depends? It depends on volume. How? Since gas expands, its volume increases. Since gas expands, its volume increases. That's why we say internal energy is a function of volume. So students, you know, kinetic energy is a function of temperature. I mean, when temperature increases, internal kinetic energy increases, and also potential energy is a function of volume, and its unit is your joule also. But students, if you consider an ideal gas, suppose in this container ideal gas is placed. For ideal gas, the intermolecular force is zero. I mean, there is no intermolecular force of attraction between molecules in case of ideal gas. Since no intermolecular force, that's why its internal potential is zero. So what we say? The internal energy is only kinetic, not potential, because internal potential is zero due to absence of intermolecular force among molecules for ideal gas. So we can conclude for ideal gas, your internal energy is the internal kinetic energy. So in this video, you know what is heat, work, internal energy, their unit, and also we differentiate work from heat. And importantly, you know in which case work is positive, work is negative, and heat is positive, heat is negative. Okay, students? Actually, in thermodynamics, this heat and work are not variables. You can say these are state variables, like your pressure, volume, temperature. So heat and work are not state variables. Actually, these are mode of energy transfer to a system. Okay. So this much.